Okay, now we're going to talk about the binomial expansion. Question number 1, which of the following terms would appear in the expansion of x plus y to the 6th? If you look at a lot of expansions with different exponents, you're going to notice something very interesting. So let's look at the expansion of x plus y to the 4th. What do you notice about all those terms? Focus on the exponents. Since there's no y, it's y to the 0th. We know that anything to the 0th power is 1. So notice that the x's, the exponents on the x's are going down and the exponents of the y's are going up. And for each term, the sum of the exponents is equal to 4. Y to the 0, x to the 4th, the sum of those two exponents is 4. X to the 3rd, y to the 1st, sum is 4. Sum is 4. X to the 1st, y to the 3rd, sum is 4. And that would really be an x to the 0. That's a 0 right there. The sum would still be 4. So now we have x plus y to the 6th. How about the first one? Is the sum of those exponents going to be 6? No, because there's an invisible 1 there. So if you add those exponents, you're going to get a sum of 7. So that one could not be in the expansion of x plus y to the 6th. Second one, the sum of the exponents is 7, could not be in the expansion of x plus y to the 6th. Third one, the sum of the exponents is 6. The fourth one, there's an invisible exponent of 1, which gives us the sum of the exponents is 6. So that number 3 and number 4 could be, number 3 and number 4 would appear in the expansion of x plus y to the 6th. Now they would have coefficients that we would also have to figure out, but right now we're just talking about the variable parts. What is the coefficient of x to the 3rd, y to the 3rd in the expansion of x plus y to the 6th? First of all, we notice that the sum of the exponents is 6, which matches the exponent on the expansion. So now we need to look at the coefficients. How do we get the coefficients? There's two ways to get the coefficients. You can either get them from Pascal's triangle or using combinations. We would use 6, choose 3. But in this case, we're just going to use Pascal's triangle. This is the 6th row. This would give you the expansion of x plus y to the 5th. We need to go to the 7th row to give us x plus y to the 6th. So how do you get the next row of Pascal's triangle? So how do I get the next row of Pascal's triangle? Well, the first thing I do is there's 1s on the ends. So how do I get the next number? Well, you need to add these two numbers and put the number below in the middle. Next, you're going to add these two numbers and put the number below in the middle. Add these two numbers below in the middle. So now we want the coefficient of x to the 3rd, y to the 3rd. So the first one would be x to the 0th, the fourth one x to the 3rd. So 20 would be your coefficient of the term that had x to the 3rd in it. So we would have 20, x to the 3rd, y to the 3rd. Next, what is the coefficient of x to the 3rd, y to the 5th in the expansion of x plus y to the 8th? First of all, we notice that 3 plus 5 is 8, which matches the exponent on our x plus y. So now we need the coefficient. We have two choices. We could either continue Pascal's triangle out to the 9th row. If we are looking for x plus y to the 8th, we go to the 9th row. This is the first row, so to get x plus y to the 8th, we need to go to the 9th row. Since we do not want to expand Pascal's triangle all the way to the 9th row, we're going to use combinations. So 8, choose 3. Where did we get the 8? Right here. Where did we get the 3? Right here. It would also be the same if we did 8, choose 5. It would work out the same, but we're choosing 8, choose 3, and we're going to do combinations. So what does 8, choose 3 equal? So we put 8 factorial on the top and 3 factorial on the bottom. Then we subtract 8 minus 3 and put 8 minus 3 factorial. 8 factorial over 3 factorial, 5 factorial. Now we can see that it would be the same. If I did 8, choose 5, it would work out the same. Okay, so what does 8 factorial? It does not mean 8 exclamation point. It does not mean shout 8. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So let's write that out. We have 8 times 7 times 6 times 5. I didn't write the rest of it out because I knew I would have a 5 factorial on the bottom. Those are set up nicely to cancel. 3 factorial is 3 times 2 times 1. So let's cancel the 5 factorials. What else can we cancel? The 3 and the 2 can cancel the 6, and we're left with 57. So 57 is the coefficient, x to the third, y to the fifth. Now we're going to do x to the third, y to the fifth again, but notice now we have this extra 2. So what is that going to look like? We're going to do 8 choose 3. 8 came from the exponent on that you're going to expand, and 3 came from the term. But now, instead of x to the third, we have to have 2x to the third, y to the fifth. Well, we already worked out 8 choose 3, so that's 56. 2 to the third is 8. Multiply that together, and we get 448 x to the third, y to the fifth. So when you're doing an expansion of a binomial to a power, you can either keep expanding Pascal's triangle or use combinations and factorials. What row gives us the coefficients of x plus y to the ninth? Remember, this is the first row, and this is the second row, and this is the third row. That makes this right here the ninth row. Next, so what is the definition of n choose r? N factorial over r factorial, and on the bottom, we next put in n minus r factorial. So there's the definition. In the expansion of x plus y to the nth, what is the coefficient of x to the k, y to the n minus k? So we're doing n choose k. So n choose k is n factorial over k factorial times n minus k factorial. For the expansion of x plus y to the nth, for any term, what are we going to get when we add those two exponents? When we add those two exponents, we will always get n, which is the exponent on the outside of your original binomial. The coefficients of x to the a, y to the b are the same as the coefficients. Remember, Pascal's triangle is symmetrical. X to the a, y to the b would be on the left. That means x to the b, y to the a. The coefficients are the same. The coefficients of x to the n and y to the n both equal what? So if n is the power on the x plus y, x to the n is either the very first term and the very last term. So according to Pascal's triangle, the coefficient of the very first term and the very last term is always going to be 1. Now, if we had a number in here, then that would come into play as well. But as long as it's just a x with a coefficient of 1 and a y with a coefficient of 1, the coefficient that we get from Pascal's triangle will always be 1.